Hi everyone, welcome to JMR Chemistry Hub. Our today's topic is spectra. A spectra is nothing but a graph which is showing a intensity of light being emitted or absorbed or transmitted by a substance. That means if any substance is absorbing or emitted a light and which is fall on a photographic plate, and on the photographic plate you can get the what are the different type of the lights are emitted or absorbed by this substance. So it is called spectra, and the spectra is divided into two types: continuous spectra and discontinuous spectra. Continuous spectra is nothing but the spectral lines are present without any gap. Without any gap is nothing but all the spectral lines are present continuously without any empty space. Best example for the continuous spectra is VIBGR. When you see the VIBGR, all the 7 colors are continuously present without any gap. And discontinuous spectra is nothing but the light lines are present discontinuously. Is nothing but these are divided with a empty space. The different wavelength lights are present here, and these different wavelength lights are separated with a empty space. So that's why these are look like a discontinuous. There is no continuity in the arrangement of the lights. So they are divided with a gap. So this type of the spectra is called line spectra. And the line spectrum or discontinuous spectrum is divided into two types. One is the emission spectra, next one is the absorption spectra. Emission spectra is nothing but when an excited electron. So excited electron is nothing but the electron which is present at the higher energy level is coming into the lower energy level. That atom will lose the energy, and by using that energy you will get the spectra is called emission spectra. For example, hydrogen spectra. So the hydrogen spectra is the best example for the emission spectra. And absorption spectra is nothing but when any atom is absorbing the energy, the lower or ground state electron will move into the higher energy level. In that process, that atom or molecule can absorb some amount of energy or some wavelength of energy, and the remaining light will be fall onto the photographic plate, and that is called absorption spectra. To understand this one, let us come to a diagram. So in this, we have the two types of the spectra. One is the emission spectra, next one is the absorption spectra. Emission spectra. How we are getting emission spectra? You have to take the first one excited molecule or atom, and this excited atom can release the energy. So in that process, the higher energy electron will move to the lower energy, and that atom will lose the energy, and according to this energy are getting the spectra. It is called emission spectra. And when you come to absorption spectra, we are getting first you have to pass the light into the any one of the substance. The substance will absorb the certain wavelength energy, and remaining energy will be enter into the photographic plate. So here it is emitted light, here it is the light which is remains after the absorption. So in case of the absorption, spectra? The spectra is obtained by remaining light after the absorption. Remaining light is nothing but, so when this light is fall onto the substance is absorbing some wavelength light, and some wavelength light will be releases, and the released light will be fall onto the photographic plate, that is called absorption spectra. And when you compare the emission spectra and absorption spectra, these are entirely opposite. What is the meaning of the opposite? In case of the emission spectra, where you are getting the bright lines, at the same place here you will get the dark space. So that means here it is the emission spectra where you are getting bright lines. At the same place in the absorption spectra, you will get the dark lines.